41 through 60. Let's go. All right, 41. We use median instead of mean when I reported the SAT. Graphical display shows the data was skewed to the right. So remember that takes your approximately normal and yanks this right-hand leg out. So we get this, which pulls the mean that direction, but the median's chilling over here. Which of the following explains why the median is a more accurate indicator than the mean is? So the median is half the data is below the median, half the data is above the median. And if I start changing the data, like if I take a point above the median and just move it way bigger, it doesn't move the median. It's still half the numbers are above the middle. So if you have like 3, 4, 5, or even just this simple, your data is 4, or your median is 4, and your mean is 4. So those are both true. Well, if I just take that 5 and turn it into a 50, my median doesn't change. Still the one in the middle is still 4. I just moved the average way up because that's like a crazy long tail. The median did not change. So 41 is it. Mean is affected by the skew and the median is not. All right, 42. Two statistics most likely to change when an outlier is added to a small data set are the mean and the median. So if I have a small data set, let's make it tiny. 4, 5, 6, 7, 8, 9, whatever. Okay, so the median here would be 6.5. If I had an outlier, so remember an outlier is going to be really far away. So let's say it's 100. Well, my median would just kind of bump over a little bit because now instead of 6 numbers, I have 7. So now my median would be 7. So it barely changed. But my mean, my average, when I total up these and then divide it by 6, I got a small number divided by 6. And it should come out to 6.5. Well, now I'm getting a much bigger number divided by 7 instead of 6, but the number I added was so much bigger, it's going to pull the mean way up. The median is probably not going to change much. I don't like this question very much because you don't know how far apart they are. It's like which are most likely. It's a little goofy to me, but they didn't ask me. 43. Let's see, 105-year-olds and 50-10-year-olds. Favorite color. So I'm going to jump to the answer. The answer is A. Percentage of 5-year-olds who selected red or blue. That would be 56 out of 105-year-olds. Is greater than the percentage of 10-year-olds who selected red or blue. Well, red or blue for 10-year-olds was 7 and 12, so 19, and there were 50 of them. So 56 divided by 100 is higher than 19 out of 50. And that's going to be it. 44. So ice cream, which of the following is not supported by the table? So flip the page here. The answer is E. It's not supported that one half chose vanilla or chocolate. So let's go back and take a look at it. They don't total these up for me, which is not very friendly. So let's add them up. So 165 plus 35, that's 200. This is 300 people. In the survey, 165 of them have vanilla or chocolate. It says one half. 165 divided by 300 is a little bigger than one half, so that is not. 45, we got this pie chart. Some questions over here. So the answer is B. More delays were caused by weather than all other reasons combined. And, the weather is 70%, and if you add up all of those, it's only going to be 30. So B makes sense. 46. Which of the following is true about a distribution that appears to have a gap when displayed as a histogram? That means there was no data there. So that would be, I'm recording ACT, or let's say SAT scores, 200, 800, 1200, 1600. And I get some scores, and I got, I got this, I got this, I got this, I got this. And then maybe I got a chunk over here. Really, it'd be like most people in the middle here. But if there's a gap, that means nobody got that score. So the distribution has a region between two data values where no data were observed. So 46 is B. 47. Top 25% have typical gas mileage of at least how many miles per gallon? So the top 25% is, so this splits it, 25% there, 25% there, 25% there, 25% there. So above 35 must have at least 35. That one is D. 48, you don't have to do. That is D. That's the formula for how you find standard deviation if you're interested. Don't worry about it right now. 49. Group mean square. RMSE. Look at this. 2 RMSEs, and then see what they're asking here. All right. RMSE is like an advanced stats term. We don't get into it in this class, but they just kind of threw it in a graph. You don't even know what it is, though. This is skewed to the right. This is probably a little skewed to the right. And then we're looking at the median and the range for those two graphs. So the range, we got 0 to 1.6, and I've got 0.4 to 1.4. So the range for mining is smaller. That's not an option. They say the earthquake is smaller or the earthquake is equal. The mode, what about the mode? So the mode here is this bar, so it's the tallest. The mode here is this bar, so it's the tallest. Those are not equal. So then what about the median? That's the one that's left. So the median is that spot where 50% of the data is above you and 50% of the data is below you. So for the median here, it's probably, just eyeball, it's around there. And then over here, where half the data is below, is probably, I could find it, 0.35, 0.55. So I know 55% of the data is below this. So the median's even a little more to the left, and it's definitely smaller in the earthquake. So the median is smaller in the earthquake, so that would be 49 is B. For 50, we got a vertical box plot here. So what are we looking at? You got to be at least 48 inches tall to ride the attraction. 48 is right there. What percent of the people could ride the attraction is approximately 50%. You got 25% there and 25% there. All right. 51. So when you change the size of the histogram bar, instead of going, okay, I know there's 4 between 0 and 200. But if I change that and say, okay, I'm going to make the bars 0, it could be that there's 4, or I'm sorry, make the bars 100. There's 4 between 0 and 100, and there's nothing there. Or it could be, so you got, let's say there's 7 in this one. You might have like 1 here, and 6 there. And you just don't know what the distribution looks like inside of this. It's kind of like a big picture, but if you zoom in, you might be able to see some weird things in the shape. So the heights don't necessarily stay the same, like we just showed that. The widths would not stay the same, they would be cut in half. The number of bars would double. The shape of the distribution, I don't know what's going to happen, because it could be anything. But the sum, so if you just add up all the data points, there's still going to be the same number of data points. So 51 is D. 52. Heart rates, beats per minute, 20 to 30, and then 40 to 50. 60, 62, and 84 were common in both samples. Okay, so we got 60, 62, and 84 are outliers in the 20 to 30. And they're saying, are any of those outliers in the 40 to 50 also? Okay, so let's do some IQR, 1.5, all that fancy fun calculation. So the IQR here is 6. So Q3 plus 1.5 times the IQR is 76 plus 1.5 times 6, which is 25 times 6 is 9, plus 76 is 85. So there are no, so you need to be bigger than 85 to be an outlier, which means 84 is not. So this guy is gone. This guy is gone. What about the other way? Q1 minus 1.5 times the IQR. So that's going to be 70 minus 1.5 times 6, which is 61. So anything lower than that is an outlier, which means 62 is not, but 60 is. All right, 53. So he's going to say, I don't know how far this hotel is. I think it's about 20 miles, but I want you 5 people to go drive, measure it, and then I'll take the median. I'll take the middle. I'll put your numbers in order from low to high and take the one in the middle. So I'm not going to average them. I'm going to say if you're one of the 2 highest, you don't count. 2 lowest, you don't count. I take the one in the middle. So why would you do that is what this question is asking. Odometer reading could be considered a variable. Yeah, so everyone's car might have a little different variable. Yeah, so I'm just going to go to the answer. The answer is C. The actual distance should be considered a variable because we don't know it. And taking 5 measurements allow us to estimate. So it's just the idea, like the more, if I said, hey, guess my weight, and you as one person guess my weight, or I said, hey, guess my weight, you 5 people, and I'll take the number in the middle. The 5 people take the number in the middle would be closer because you have a method to get rid of bad answers, a method to get rid of errors. So you should have less after you do that. All right, 54. The answer here is E. Which of the following statements must be true? So if I just jump to E, the difference between the median and the lower quartile is less than 2. Well, the median is there, and your lower quartile is there. And if you can I kind of drew over it, but those things are 2 apart, these little tick marks, and that's smaller. So it's got to be E. 55. 20 men and 20 women, so this is one of those that try to trick you right away. More people in the first and third quartiles? No. There's 25% of the people in each quartile, so 25% of 20 is 5. You got 5 people in each quartile. Let me just jump to the answer though. So the 55 is C. At least half of the women had higher pulse rates than at least 3/4 of the men. Okay. Well, the 50% of women with the highest pulse rates are there. And then 3/4 of the men are down there. So yeah, all these are higher than all of those. So let's see. 56. So we got Q1, Q2. Remember the Q2 is the median. And then Q3, which of the following must be true? Well, let's see. So the answer is A. At least half the customers spent less than or equal to 44.27, and at least half spent greater than or equal to 44.27. That is your answer. 44.27 is the median, so half the scores are below it, half the scores are above it. The reason it says at least is you could have something like this, where your customers spent 40, 44.27, 44.27, 44.27, 45. So your median there would be 44.27, but it's not even necessarily true that only half are. It's even more than half, because you take the half that are below that, but then there's some in the upper quartile too. 57. Back stub and leave, dropped out at 49 high schools. Which of the following is not justified? So make sure you see that word, not. Let's see. So the answer is A. Dropout rate decreased each of the 49 schools. Well, I have no idea. I mean, yeah, these numbers in general are a little lower than those, but I don't know that, like, specifically the biggest one dropped to here. This one dropped, this one dropped. Like, on average it dropped, but that doesn't mean every single situation dropped. 58. They say, which of the following is the mean greater than the median? Well, if the mean is to the right of the median, It must have gotten pulled that way. So it must have been skewed to the right. I'm really sorry about these camera. I'll get better at this, but we're looking for skewed right here because the median's probably around here, and then the mean would be way over there. This they'd be the same because it's symmetric. This they'd be the same because it's symmetric. This they'd be the same because it's symmetric, and this would be the opposite, where the mean is smaller. So 58 is A. 59 is C. So I've got this kind of skewed left deal going on. And what that means is the mean gets pulled this way. And it's going to be lower than the median. And because it's skewed left, so that's C. It's straightforward definition of do you know what skewed left means? Which of the following are the 50th percentile? So the 50th percentile means half of your data is above it, half of your data is below it. And that's the definition of the median. All right, let me stop there. That's 41 through 60.